All right, here we go. Unit 1, Lesson 4. Rewriting formulas and equations. So wanted to just point out that here's some kind of common equations. So, if you get to a problem, you can't remember how to turn degrees to Celsius or Fahrenheit to Celsius or what the area of a triangle was. You can always reference this back. You can always look back at this and remind yourself. Let's get into our first example. So our first example is rewriting a formula with two variables. So let's say that we have the circumference formula equals 2 times pi times r, 2 pi r. But because pi is kind of a tricky one, because again, it never ends. So I actually like to write this formula as 2 radius times pi. Now, think about multiplication. 3 times 5 or 5 times 3 is the same exact thing. So we're not changing the problem, but we're going to keep pi in terms of pi. So that's why I like to put the radius there. And the question is, find radius if the circumference equals 44 inches. Okay, circumference equals 44 inches. So what I need to do is, my goal is to find the radius, correct? So that means I need to get r by itself. Now I'm going to plug in what I know. So I know that the circumference is 44. So I'm going to plug that in. Come on. There we go. 44 equals 2 times the radius, which we want to get by ourselves, times pi. Now, my goal is to get r by itself. So that means I need to divide by 2 pi on the right side. And anything I do on the right side, I also have to do on the left side. So just a reminder, again, if you have something on the top and on the bottom, it cancels out, which means we are just left with r. Now, 44 divided by 2 pi is kind of a tricky sort of answer to solve. So we're going to use our calculator. Okay, and I'm going to type in 44 divided by, and I'm going to use parentheses to show 2 times pi. And you can see that our answer is about 7.002817. Again, pi never ends, so we're not going to get a complete answer. Now, there's 2 ways to write this answer, okay? So again, we could say that our answer is 44 divided by 2 is 22. So we could say it's 22. No, we can't do that because, again, we have to multiply what's on the bottom first. Therefore, we're just going to say r is approximately 7 inches. Again, because our answer was 7.00. You could round that up and you could say 7.003. But I'm just, again, because we have that word approximately. On an exam, I would tell you specifically if I wanted you to round to 2 decimals, 3 decimals, okay, something like that. So that's our first example. What about if we have a formula with 3 variables? So this time we're looking for the perimeter of a rectangle. Okay, so I'm going to draw my rectangle. I'm going to say the perimeter equals 41 meters. So perimeter, add them all up. That's the outside. I'm going to call my length 12 meters and my width W. I'm not sure what my width is. And kind of your average formula for perimeter is P equals 2 times the length plus 2 times the width. Again, rectangles, this side is the same as this side. This side is the same as this side. So that's how I get 2 times my length, 2 times my width. I could do 12 plus 12, or I could do 12 times 2. It's the same thing. So I'm going to fill in what I know. Okay, I know that the entire perimeter, P, is 41. I know that the length is 12. I don't know what the width is. So first thing I'm going to do is I'm going to multiply this right here. Oh, that's the wrong button. I'm going to multiply this right here. 2 times 12 is simply 24. And now again, I need to get W by itself. So I'm going to work PEMDAS backwards. PEMDAS. I'm going to work it in reverse order because that's how we undo equations. So if I see that I have addition or subtraction, right here I have a positive 24. So I'm going to subtract 24. I'm going to subtract 24. This cancels out. 41 minus 24 is 17 equals 2 times W. Therefore, I'm going to divide by 2, and my width is going to be 8.5. So again, the question was to solve for W, find the width, and we were able to do that. And because my units were meters, I should say 8.5 meters. We may have to rewrite a linear equation. Okay, so let's take different color here, maybe green. I'm feeling green right now. Solve 9x minus 4y equals 7 for y. Okay, so our goal is to figure out what in the world is y. Then find the value of y when x equals 5. So let's just write, then find y when x equals negative 5. So the way the question's worded is they want me to get y by itself first. So I'm going to write my equation over here. 9x minus 4y equals 7. I'm going to work PEMDAS backwards, okay? So again, I have a positive 9x here. So the first thing on the left side that I'm going to do is get rid of this positive 9x because my goal is to get y by itself. And I'm going to subtract it over here as well. So now I'm left with negative 4y equals 7 subtract 9x. Negative 4 multiplied by y, the only way to undo multiplication is with division. Now remember, you have to divide everything. You can't pick and choose specific, you can't just divide 7 divided by negative 4. You have to divide the whole thing. And this way I can do a negative 9 divided by negative 4 is actually a positive 9. Negative divided by negative is always positive. Now, since I've solved for y, I can plug in my x value. Okay, I can plug in my x value and start answering this question. So negative 7 over 4 plus 9/4 times, again, this is negative 5 over 1. So let's kind of simplify this. 9 times negative 5 is negative 45, and 4 times 1 is 4. So if I have negative 7 over 4 plus negative 45 over 4, do we have the same common denominator? Because if we do, we can combine them. So negative 7 plus negative 45 equals negative 52 over 4. When you add fractions, you add the numerators, which is the top, you keep the denominator the same. So now I got to think, how many times does 4 go into 52? And it's actually 13, but a negative divided by a positive is a negative. So I can solve for y by getting y equals negative 13. All right, next example. What about if we have a nonlinear equation, okay? So this problem, feeling blue. Solve 2y plus xy equals 6. We want to solve for y and then find the value, then find y when x equals negative 3. All right, so I'm going to write my equation, 2y plus xy equals 6. And now I have to think, do I have anything in common that I can maybe factor out? And the answer to that is yes, because we have a y in both of our terms. So I'm going to factor out a y and be left with 2 plus x equals 6. So I want you to think about the distributive property real quick. Again, y times 2 is 2y. Y times x is xy. So I'm not changing my problem. I'm just changing how I write it. Gotta get blue. And now the last step, again, this is y times whatever's in my parentheses, y multiplied by whatever's in my parentheses. You undo multiplication with division. So I'm going to divide both sides by 2 plus x. This cancels out. All I'm left with is y equals 6 over 2 plus x. Solve for y is done, okay? This is how we solve for y. Now let's take this and plug it in here. So y equals 6 over 2 plus negative 3. Well, if I simplify my right side, 2 plus negative 3 is simply negative 1. 6 divided by negative 1 is negative 6. So I get an answer of y equals negative 6. Last example, one more color, because why not? Let's use brown. Is there more colors on here? Let's check it out. Oh, shoot. Oh my goodness, look at all those. What are those? Those are empty. Huh. Okay, we got lots of colors. Sweet. So the question is, a video store rents new movies for one price and older movies for a lower price. Write an equation that represents the store's monthly revenue, solve the revenue equation, and then they got specifics. So new movies cost, this is an old example, no one rents movies anymore. Netflix, Hulu, Amazon Prime Video. Should change this to subscription services. Older movies are $3. So again, it's always good to kind of use a verbal model. So we're going to use our monthly revenue, how much we make total, equals the price of a new movie multiplied by the number of new movies rented plus the price of an old movie multiplied by the number of old movies. Running out of room. Oh, kind of running out of room here, but the number of old movies. So now we can plug some stuff in. The one thing I forgot to say is the owner wants $12,000 in revenue per month. So our overall arching question is, how many new movies must be rented if the number of older movies rented is 500? All right, so total revenue is going to be $12,000. Okay, that was given to us in the problem. So I've got $12,000. That's my goal for my monthly revenue. I don't know how many I know the price of a new movie is 5. I don't know. I'm going to use N for new. Okay, N equals new. So I'm going to do 5 times N plus the price of an old movie is $3, but I know that I rented 500 old movies. So again, if we kind of want to figure this out, we're going to say, 5N plus 3 times 5 is 1,500. Okay, this is still 12,000. I'm going to subtract 1,500 from both sides. That's going to give me 10,500 equals 5 times N. But now again, I want to know how many new movies do I have to rent? Well, if I divide both sides by 5, and let's say I don't know what this is off the top of my head. Okay, let's use our calculator. 10,500 divided by 5. 2,100. Holy smokes. So if this person wants to make $12,000 in monthly revenue, they need to sell 2,100 new movies. And so again, of course, if they had different numbers, say that they said, hey, we sold 1,000 old movies instead of 500, all you